All right, because our method for solving for an inverse of a matrix is pretty messy and it involves a lot of row operations a lot of times to find the inverse of at least a 3x3 or a bigger matrix. And 2x2s aren't too bad, but 3x3s, you'd want to use a calculator. And one that I'll show is using Symbolab. So if you type in Symbolab matrix, and I get this first result here, matrix calculator. And what you can do is you can pick different size matrices. To find the inverse of a 3x3, we'll actually need a 3x6, and that's not shown here. So you can click on this here and get 3x6. All right, and you can type in your matrix A on the left and the identity matrix on the right. Now, I actually already have one typed, so I'm just going to paste that in here. So here I'm trying to find, I'm not sure why there's spaces there. Let's erase those spaces. I'm trying to find the inverse of 1, 2, 3, 4, 5, 6, 7, 8. Actually, just for this example first, I'm going to change this 9 to a 1. So I'm trying to find the inverse of that matrix. If we augment the 3x3 identity matrix, and then we reduce it, and when I click go, it'll reduce it for us using those row operations. All right, so using the row operations, it shows the identity matrix on the left. So that means it got it in reduced echelon form. That's good. And we talked about in the previous video that this right here is the inverse of my matrix A. And it looks messy, and that's kind of a hint that, yeah, you wouldn't want to do the row operation by hand. That'd be really messy. But anyways, if you took this matrix, extracted it out of there, and multiplied it by 1, 2, 3, 4, 5, 6, 7, 8, 9, right, do the matrix multiplication, you'd get the identity matrix. So this matrix on the right is the inverse of what we typed in. All right, now I want to go back to changing this to a 9 and show you what happens. All right, and click go. I'm just going to do the row operations to reduce that new matrix. And what we see is, well, it's in reduced echelon form, right? You got the leading ones and the zeros everywhere else in those columns. I'm just going from top left to bottom right for those leading ones. So it's in reduced echelon form. That's good. But what we see is the left-hand side, right, that left 3x3 is not the identity matrix. So that means the original matrix we're looking at is not invertible, right? Because we did not get the identity matrix on the left, right? So the thing that you see on the right, that right-hand side 3x3 matrix, that is not the inverse of our original matrix, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? If you multiply those two together, it will not give you the identity matrix. So this is just not the inverse of our matrix A. And that matrix A is not invertible. There just doesn't exist another matrix, if we call it B, such that A times B is equal to I. It's just impossible. Another way to think about it is, let's just look at this 3x4 piece here, right, the 3x4 piece. And we can look at the original 3x4 piece. Well, what does that represent? Well, that represents us trying to solve for the first column of B, right? Because we're trying to solve for A times the first column B equaling 1, 0, 0. Right, so that's like the first piece of trying to make A times B equaling the identity matrix. So we want A times the first column of B to be 1, 0, 0. Well, if we just look at the reduced echelon form for that 3x4, right, we see that bottom row is a contradiction. We get 0 times the first entry in B1, plus 0 times the second entry in B1, plus 0 times the third entry in B1. That is column 1 of B. Equals to a non-zero number, right? Equals to 1. And that's a contradiction. That's what we've talked about before. That's a system of equations that has no solution. In this case, a matrix equation that has no solution, right? 0 times something plus 0 times something plus 0 times something is never equal to 1. So it's a contradiction. That means it's impossible to have matrix A times a vector that would represent our first column of our inverse to equal 1, 0, 0. It's just impossible. That means our matrix here is not invertible. All right, so this video was an example of using Symbolab to use it's using row operations for us, and we can find the inverses that way, right? Because doing it by hand is pretty messy. And that's it for this video. Thank you.